Hey everyone, thanks for joining us here. We're got a couple more really exciting startup pitches. Very excited to have these guys talk a little bit about their businesses. We're going to start off with Iddo Geltner. He is the co-founder of Arugga, an AI farming company based in Israel. Manufactures autonomous robots, transform greenhouse vegetable farming. Prior to founding Arugga, Iddo was the vice president of R&D at Dune Medical Devices. So Iddo, if you want to go ahead and take it away here, I'll have you share your screen. And Gary, if you don't mind minimizing your screen.
Okay, let's see. Where do I minimize it, Rob? Well, you operate it. He's asking me to minimize it.
Iddo, you want to go ahead and share? Yeah.
Great. I'll share my screen.
There
Perfect.
we go. Operate this. Here, put one in there. There you go.
Great. So you can see me, hear me, and see my screen.
Yep, we're good to go. I'm going to focus you here.
Great. So hi everyone. I'm Iddo Geltner, co-founder and CEO of Arugga. We're a startup company based out of Israel, and I'm excited to be here and to have the chance to tell you about our company. So we are developing autonomous robots for greenhouses to treat and monitor every plant. And our first focus is on tomatoes, which is the largest crop in greenhouse farming. And on the screen, you can see a breakdown of problems that growers in the greenhouse tomato sectors have. But specifically in greenhouses, the main issue is labor. That's not only the largest cost, but there's also the indirect costs of due to shortages and turnover of labor, primarily due to loss of quality. But these indirect losses are hard to quantify. And in addition, in tomatoes and other greenhouse crops, there's the issue of pollination, usually done by commercially produced bumblebee hives. But these bumblebees are sensitive to environmental conditions and pesticides. They don't come out to pollinate when it's too hot or too cold. They also pollinate when they want to and not when it's optimal for the plants. And in addition, they spread viruses. Now, just recently, for example, the Department of Agriculture in Florida issued a warning after discovery of the Tubama virus in the US. And they also mentioned the bumblebees as one of the vectors of the virus. This is known also in the literature. These hives are also not available everywhere. For example, in Australia and other countries where they still perform pollination manually at a much higher cost. So as a first step into the market, we decided to start with a pollination robot. Just like to mention before I move ahead, that tomato flowers are self-pollinating. They need a very gentle but accurate vibration in order to release the pollen on the stigma, the female organ, for fruit setting. So you can see here some snapshots from a video of our first prototype being tested in a commercial greenhouse in Israel. Our robot will autonomously scan the rows, and using AI-based image processing will detect flowers that are ready for pollination. And then it will aim a nozzle and send very accurate and calibrated air pulse to vibrate the flowers. Now you can see the full video on our website to see exactly how it's done. Now we just recently completed the very first experiment in a commercial greenhouse in Israel of our first prototype. We have fantastic results. The main parameter, of course, for comparing is the weight of the tomatoes. We compared in our study the pollination of a robot relative to bumblebees and also manual pollination. We separate an area in the greenhouse with a hail net in order to prevent bees from entering this area where we can pollinate with a robot or manually, and then the bees pollinate outside where we have a control area. You can also see that there's a reduction in disqualification of tomatoes, in this case, especially due to size and a little bit more deformities. and there's no deterioration in one of the main qualities of the quality parameters, which is the sugar content measured by Brix. Now, this study is supported by quite a few experiments that we did in the past couple of years, where we use the same kind of air pulse mechanism, just manually, in several instances where we tested in commercial greenhouses 4 different varieties of tomatoes, one of them even snack, compared to bees, and we always see results as good as or better than the bees, and these are in conditions which are optimal for the bees. So once these robots are deployed, we'll develop and add additional modules, either by our own development or collaborations with third parties. For example, in yield prediction, we're collaborating with the Agricultural Research Organization in Israel to commercialize some unique technology for yield prediction, which is not based on vision. So it has several advantages over image-based yield prediction and monitoring. We'll, of course, develop stress detection, pest and disease, but our first module after pollination is non-contact flower pruning. Now, flower pruning is a very labor-intensive task. Employees walk around the greenhouse, and they have to cut every truss in every plant in order to limit the number of tomatoes on a truss to approximately 5. So what we did is we did some feasibility testing that by applying heat for a few seconds on flowers or flower buds, we can prevent fruit setting. As you can see on the slide, 2 cases, flowers are marked with a small plastic ring in blue on the top and pink on the bottom, and we've damaged those flowers and followed them for 21 days, and you can see that there's no fruit setting. Even on the lower case, you can see that there's even no visible damage. So once, what's our plan? We are headed to start commercial pilots very soon in Israel and in Australia. We hope to launch this commercial product before the end of the year, and we'll follow that by some monitoring abilities that will slowly add more and more of these features using our multiple cameras that are on the robot already for detecting the flowers. And of course, next year, introduce non-contact flower pruning. So I'd like to thank you all. This is from our wonderful team in Israel. We have a very multidisciplinary team. My co-founder, Eitan Heller, is a veteran of solar energy businesses, and we have very experienced agronomist and mechanical engineer, also AI and robotics specialists, and we recently added to our team a programmer. And thank you for listening. Take any questions that you have.
Great, thanks. Yeah, I'm going to come back. I want to say one question that I do have for you. I noticed that you had your end of year kind of projection. Is that a COVID adjusted thing? Is that anything that's impacting your ability to deploy this? How is that kind of playing into your timeline here?
Yes, this is our original plan. I think we'll meet it. The pandemic hasn't affected our business a lot, but it's indeed creating some problems, logistic problems. Sending a robot to Australia has become a huge issue, but our robot made it there. But we're on track with our plan, and hope we complete it as we expect.
It's great. Yeah, good for y'all. And then I noticed also, it looks like on the website, it mentions that this device has the potential to add some additional modules to it. Is that something that you guys are I'm obviously thinking forward about that? Do you have any plans in that space? Is that something that you're currently working towards, or more focused on kind of getting this out and into market?
So we're very focused on getting this into the market. You know, we're a small company, especially now with limited resources. But we, as you saw in my presentation, we are starting to think and talk with growers about the next modules. We also did some feasibility testing on non-contact pruning. And we definitely think that the main advantage of a ground-based robot is to add more and more modules on it as time goes by, and commercially increase our revenues per hectare and per unit. And so it doesn't take additional robots in the greenhouse and keep the number of units running around limited. Also, ground-based robots have many advantages. For example, in pest and disease detection or other stresses, the robots can carry chemicals or materials and treat problems immediately and locally. So saving additional costs and labor, and of course, land contamination or food contamination from chemicals. So there are a lot of advantages on ground-based robots.
Yeah, absolutely. That's it seems like a really cool setup you got there with, like you mentioned, a ton of potential moving forward. So I've got a question from the audience here. How do you view the role of robotics for the future of farming? Do you think that robotics will ever replace farmers? How is that something that you guys manage internally?
So first, I don't think it will replace farmers. I think that farmers are super important. They know the job best. I think that we are here to help farmers because they have labor shortages. Some farmers do not work at full capacity because they know they won't have enough people to do all kinds of jobs on the farm. And greenhouse farming especially is so labor intensive that you can't grow your business as fast as you'd like. So I think robotics will help replace not all tasks, but several of the manual tasks and other monitoring functions that are also labor intensive and require a lot of effort.
Good, very good. So we've got another question here coming in. What have been the biggest challenges you've worked through, and what advice do you have for other entrepreneurs in the ag tech space?
Oh, that's a huge question. I think the main problem for startups in ag tech is that still a relatively young sector. So there are not a lot of VCs, not a lot of companies, no benchmarks for valuation or for exits. I think in that sense it's difficult, but it's an exciting space. It's doing some real help for the growers, and also I think that the main effect that we can have on growers is really bringing out machines that can do things, and that takes a lot of effort and funding. You really need to build machines and production lines and testings, and so it's also exciting and challenging.
Yeah, absolutely. And then we've got another question here from Lisa, pretty interesting. She asks, are you selling the robots directly? And maybe if you could just kind of expand a little bit more on your business model. Just to put it in context, one of our panels earlier, they talked a lot about robotics as a service as opposed to actually selling the robot. So is there any, if you could just kind of discuss that a little bit?
So we're definitely going to start by service and direct sales to the growers, especially large growers at first. But I think that in the long run, we plan to do some kind of combination of service and selling actual robots. In many countries, there are incentives to buy capital equipment, usually tax benefits. In other countries, for example, in Australia, they prefer to buy equipment. They don't want anybody trying to drive or fly long distances to service their robots. They prefer to do that themselves. So in our case, we can do both. It's both the preference of the grower, also financial issue. Who bears the financing expense of the cost to build the robots?
Great. Yeah, and we've got one more question here coming in from Roger. He's asking, does one module include foliage fertilizer?
What's the question?
He asks if one of your modules includes foliage fertilizer. I think he's really just maybe kind of more curious about the modules. My understanding is right now you just have the one module that's aimed towards tomatoes. Is that correct?
Right. We're just focused on the pollination, non-contact pollination of tomatoes, and in the future we'll add additional modules. But of course, there are thoughts about fertilization, especially local, very accurate fertilization of parts of the plants, which is something that's being developed these days in other companies. But yeah, we're focused on pollination in the next year.
Great. All right. Thank you very much, Iddo. Now we're going to transition over to Gary. I'm going to go ahead. If you wouldn't mind, I'll bring Gary back onto the screen. Iddo. Great. All right, Gary. So up next we have Gary Costner, who is the founder and CEO of Myco Systemics Corporation, a company devoted to revolutionizing industrial mushroom cultivation infrastructure. Gary is the patent holder of advanced 3D supercomputer architectures with extensive experience in AI and mechatronic system design. So Gary, if you want to go ahead and share your screen and take it away here.
Okay, well, thank you very much for having me here. Very good to be here, everyone. Yes, when I guess it was back in 2018, I became rather disenfranchised with the corporate culture or surrounding computers and digital technology, and decided to get into something that held my interest a little better and had a little bit more heart. And so I had always been interested in mushroom cultivation. And so pursuant to that, I moved to Olympia, Washington, where I networked with mycologists and mushroom producers to determine what were the major pain points in industrial scale mushroom cultivation. And what I found is that basically the cultivation paradigm had not shifted in several hundred years. The way that it's done currently in large industrial facilities is you have very large rooms filled with shelves lined with trays of either bags or, like I say, trays out in the open. It's virtually impossible to maintain homogeneous temperature, airflow, humidity across a large space like that, which results in inadequate yields, contamination. In fact, about 20% of the yield is thrown away each year because of either contamination or sub-marketable quality. That's the premise that we went on. So what I did was to take the same approach in micro cultivation infrastructure that I did with high performance computing, which is when I think large, I think small. So what I mean by that is in building very large aggregate systems, it's best to build them out of the smallest common denominator, which can fulfill the function and be scaled up seamlessly and economically. So that's the approach that we took with our cultivation infrastructure. Okay, so how do I go to the next frame?
Right here.
Okay, so hold on a minute. We're working out our technical issues here. Okay, so
we're not going to be able to see ourselves.
there we go.
Okay, go ahead.
Okay, so this our system, as you can see on the screen, is a scalable system. You see the very small one. That is our first flagship product. It is 26 inches by 26 inches square, 18 inches high, has a growing area of 2 square feet. The one above that, is larger one, is 1.5 meters cube. It has 56 square feet of growing area. And then the one above that is 1,000 square feet of growing area in a hexagonal geometry tower, which scales up to reach any desired quantity seamlessly just by hooking together adjacent units. We see here the current paradigm as I was describing earlier. And here we see the shelves with the everything out in the open. Clearly, if you get contamination in one area, the contamination spreads to other areas. You can lose entire rooms full of crops. Also, as I was saying earlier, you'll lose up to about 10% of your crop just by virtue of having suboptimum yield, because it's impossible to get the same level of consistency across the whole room. Now, here we see our solution, the scalable modular Mycoplex systems that have integrated microclimate control. The actual grow compartments are insertable cartridges, like you would have an inkjet cartridge that goes into a printer. This is a Myco cultivation cartridge, which we call a Mycopod. It comes pre-assembled, preloaded with substrate and casing, inoculation ready, pre-sterilized, pre-pasteurized. You just unwrap it, inoculate it with the spores of your choice, insert it, hit the go button, and it informs you when your first flush is ready for harvest. Now, the reason that this is appropriate now is we have an explosive adoption of mushrooms, obviously for their high nutritional and medicinal value. Psilocybin mushrooms, which are gaining in popularity, have been designated breakthrough therapy by the Food and Drug Administration to cope with the epidemic of mental health issues. And we have accelerating regulatory changes and decriminalization. The market size, let's see here, this thing is unwieldy here. The market size is, we're looking at a total addressable market of around $70 billion by 2024. The served addressable market for that is roughly 50% of that, and our calculations indicate that we're looking at about 3% of the served addressable market, or approximately $1 billion in 2024. And so here, once again, we see the product family. We see our microclimating, optional pre-harvest dehydration. The grow cycle is completely automated. We have intelligent monitoring. We're utilizing AI and machine learning to examine the data from each and every harvest, because everything, all the parameters are monitored in real time. We have easy retrofitting, and we are in the process of doing retrofitting for robotic cultivation. So the benefits we have in being modular, scalable, compact, cost efficient. It's a turnkey system, set it and forget it, fully automated, and produces a much higher yield because of our optimum parameters than can be achieved utilizing the conventional means. This is the first product that we're talking about right here. You see it has a 4 square foot cultivation area, produced 16 pounds of wet product or 1¼ pounds of dry product per cycle. Set it, forget it. 6-week harvest cycle on average, even though it can be less depending upon the species. Here we see the Mycopod cultivation cartridge, and here a little transparent rendering to show how all the components fit together in the system. Now, these can be utilized for anything from a grandmother who wants to grow mushrooms in her kitchen to someone who wants to set up a medium scale industrial production facility. Here we see some of the configurations. We see a 4x6 system providing 96 square feet of cultivation area is going to produce approximately 64 pounds or 256 pounds per month of wet product, or 5 1/8 pounds of dry product per week, or 20.5 pounds per month. Right below that, we see a larger system, which basically is 4 times that capacity and will fit into a moderately small size warehouse facility. Here we see an industrial version of that, where we can stack with ceilings as high as 12 feet. There is support infrastructure. You can't see this in the back of them, to make sure that the stacks are sturdy and well anchored. And as you can see, in the lower unit, we can get up to 164 pounds of dry product per month. This is the next generation up. This is the one that is 1.5 meters cube, and will produce, in terms of actual production, wet production of 37 pounds per week, 150 pounds per month, or dry production, 3 pounds per week, or 12 pounds of dry product per month. So looking at the configurations of how those stack up, pardon the pun, is you see down on the bottom, and what will fit inside a moderately small warehouse facility will be able to grow up to 107 pounds of dry product, 428 pounds per month, or per week, 1,342 pounds of wet product, or 5,328 pounds per month of wet product, which is substantially greater than would be able to fit into the same amount of space utilizing conventional methods. Our competition is little to none at this point. As you see, we have precise control of our environment, superior contamination containment, low labor for setup and harvesting, requires little to no monitoring. It's a modular systemic architecture. We can achieve up to 4 times greater yield in the same amount of space, with immunity from climate variations, the integrated dehydration, as it was referred to earlier, ease of automation and robotics, integrated AI and machine learning, and tracking and analysis using a blockchain-based data store. So looking over here, our business model basically is to appeal to the distribution channels are do-it-yourself growers, bulk growers, processors, derivative formulators, therapeutic program facilitators, government institutional research facilities, restaurants, grocery stores, basically anyone who has a desire to grow mushrooms locally. And one of the things that we've noticed is a spike in interest in our systems for growing locally due to the pandemic that we've been experiencing, people having difficulty getting produce from the stores and the like. It's shown clearly that we have a need to go away from the centralized distribution method for food growing towards a more local, community, or even home-based growing system. The revenue sources we're looking at is we're selling direct to consumer. We're doing wholesale distribution through distributors. We have several joint ventures in the work, and then we get our reoccurring revenue from the actual cartridges that go into the systems as they are spent. The customer can send the used cartridges back. We give them a credit and replace them with ready-to-go, inoculation-ready cartridges. Now, in terms of the saving, we see here that that approximately 2/3 of the revenue from sales from the mushroom producers is taken up by labor. And our system, as it stands, even without the robotic automation that's in the pipe, will reduce that by 2/3. We also eliminate the discardants from the suboptimal yield because of the consistency in yield, in fact, the higher quality yield that we get with our system, and also from the elimination of the discarding of contamination as well. So that provides a 25% increase in revenue from that. We also get 15% more product from higher yields. And when you add all of this in together, it provides a 275% overall increase in profitability, because the grower is basically able to recover 90% of the pennies for every dollar, as opposed to making 33 cents on every dollar of revenue without Mycoplex. So that's a very significant increase in profitability. We're looking at our timeline. Basically, the thing that matters about that timeline is that we are in the process right now of rolling out our first units off the production line for our Myco mod system, the 4 square foot growing area system. In 6 months or so, we're expecting to roll out the second generation 1.5 cube system with the 56 square feet of growing area. And first quarter of next year, we're planning on rolling out our first, what we call the Myco Max Tower with the 1,000 square foot growing area. And that unit is the one where we're focusing the majority of our time and attention on. We're working with the Autodesk Technology Center and Robotics Lab in San Francisco. They pretty much own the space of mechanical engineering and robotics and the like these days.
Hey Gary, I gotta pop in real quick here. We're running out of time. Could you wrap up here? Maybe 15, 20 seconds.
I think we're coming to the end here. Here's our illustrious team. We've got a team of 14 extremely qualified people. This is our current raise right now that we're getting very good responses on. It's a $2.5 million raise. It's a safe note, $15 million valuation cap, and converted at 20% discount. We see our projected revenues for a 3-year term are very healthy. And that's pretty much it for what we're doing.
Great. That's a very interesting presentation. I wish we had a little bit more time. Would love to dive in and ask you a couple questions here. Unfortunately, we're going to have to move on to the next session. Again, really want to thank you. Thanks for the presentation. Iddo, thank you for the presentation as well. Really enjoyed both of them. So we're going to go ahead and move on to the next session. But thank you guys, and hope everyone sticks around.
Thank you so much.